We're going to do the ratio test for question 1D. So in the numerator, we're going to have an plus 1. The denominator is an. So putting in the numerator, an plus 1, we have x minus 1 to the power n. So that becomes x minus 1 to the power n plus 1. In the denominator, we have 2 to the power n plus 1. Okay, and in the denominator of this expression, we're going to just put our x minus 1 to the power n and 2 to the power n. And we probably can already guess that we're going to group these together, and we're going to group the x n's together. Okay, so simplifying this, we have the limit as n approaches infinity, and the terms, the 2n terms, we're going to write as 2 to the power n, and then the 2 to the power n plus 1 we'll just write as 2 to the power n times 2, and we'll group those together. And with the n terms, we're going to end up with x minus 1 to the power n, and I'm going to put an extra factor of n minus 1 for the plus 1. And then in the denominator, we end up with x minus 1 to the power n. So we can cancel out some terms here. So we're going to group these ones, and we're going to cancel some terms. So we're going to cancel out these terms here, cancel out these terms here. So what's left over is we have the limit as n approaches infinity. We have our 1 over 1/2, and then we have our x minus 1 term. And we're looking for where this is less than 1. Okay, so we're going to have, based on this, we can then work out our interval of convergence. So rearranging this, we're going to end up with our x minus 1. I'm going to put our 1/2 to one side. Sorry, I don't need the limit notation here. So I'm going to put the 1/2 to one side. I'm going to multiply out the 1/2 and onto the right-hand side of our inequality. We end up with 2 on this side, and then on the other side of the inequality, we multiply by 2 as well. We multiply out the 2 in the denominator, so we end up with x minus 1 must be between -2 and +2. So this represents the center of convergence. Okay, this represents our center, so C equals 1. And then when we work out our interval, we know that the right edge is going to be based off of this. The right-hand interval is going to be x must be less than 3. And in the left-hand interval, left edge of that interval, we're going to have x is going to be greater than, we're going to add 1 to both sides, so x is greater than -1. Okay, so that represents the left edge and the right edge of the interval. So at this point, we know it's got to be between -1 and +3. Okay, so that represents our interval. The radius is going to be, in this case, 2. So a radius of convergence is equal to 2. And then we have to test our endpoints to see if our endpoints are included in our interval. So we're going to test our right-hand endpoint first. So we're going to test x equals 3. And to test x equals 3, we plug it back into our original equation. And we're going to end up with, in this case here, the limit as n approaches n goes from 0 to infinity. We plug x as 3, we end up with 2 to the power n over 2 to the power n. Well, this really is just equal to 1, okay, for every n value, so this is going to be divergent. Okay, so we have a diverging right edge for this. So at this point, our interval looks like this. X is less than and not equal to 3. So then we go ahead and test the left-hand interval. So x is equal to -1, and we're going to plug that into our series. So at x equals -1, we're going to end up with -2 to the power n over 2 to the power n. So we could simplify this, and it becomes an alternating series. However, we're going to have an alternating series of -1 to the power n, so it just goes +1, -1. This still is divergent. Okay, so again, we cannot use this endpoint, so our left-hand endpoint is not equal to -1, so our interval is from -1 to 3. Okay, so we can write our interval as an open interval of -1 to +3.